Hello chaps and chapettes. Well, okay, today we're looking at potential dividers, and this one is a little bit tricky because it requires a bit of logic and you need to be thinking about how voltages work in different types of situations. So we're going to look at that now, and by the end of this video you're going to know the action of a variable potential divider and also the potentiometer, and you're going to see how this can work in light sensing and also temperature sensing circuits, so you can see what they can be used for. You should be able to draw a potential divider circuit. It's really straightforward. All you need is two resistors. I'll show you in a second. And the challenge today is to make an intruder alarm, which you should be able to do once you know how these circuits work. So, first of all, what is the point in a potential divider? Well, this circuit allows you to change the voltage between the maximum voltage given to you by your battery or cell and also zero, which is kind of difficult to do if you're just using a regular series circuit. So what we're going to do is, first of all, you're going to pause this video and draw down the circuit and write down the info, and then I'm going to show you what this looks like in terms of a series circuit first, and why that doesn't work for you and want it to do, and then look at how the potential divider solves your problems for you. Okay, so this is the potential divider setup, and it's not too complicated. We've got one resistor here and one resistor here. Now these things are my fairly bomb-proof ones, although they are getting a bit warm right now. They're made out of ceramic, so they're very heat resistant, so these things should be okay. But we've got these two resistors put up in series, and what we're going to do now is just see how we can change the voltage between them. So let's just, oh my gosh, all tangled up. Let's just see the total voltage dropped across these things, and we've got minus 2.31, fairly straightforward. And then across this one, we have minus 1.15. Now we'll ignore the minus number on there because that just talks about the direction this thing's going in. And that's basically dividing our voltage between the two of them, which is fairly straightforward on something like this. These are both 20 ohms each, so they're going to half and half. Now if we just take this one out. Okay, pop that one out. Take this one in. This one is a 10 ohm resistor. And drop that in there. There we go. A bit of blue tack to make sure it doesn't fall over, because my wiring is nuts. So there we go. We should still have the same total voltage being dropped across it. There you go. 2.2, fair enough. And then this one now should change. And we get a slightly different voltage dropped across this one. Right now, more voltage is being dropped across this resistor than this one. So we actually have the change potential difference now, which means that if we were attach a bulb to that one, we could start to play around with our potential resistances and things. So there we go. That's potential divider. Oh dear, let's just turn this off again. 1 second. There we go. So, behave. So, you might be wondering why we need a potential divider in the first place. Well, if... There, okay, stay. Oh my goodness, it's not playing ball at all. There. So, why do we need a potential divider? The thing is that if we had a series circuit like this, where it was just a resistor and a light bulb in series, if we change the resistance of this thing, we of course change the current flowing through the light bulb. Now the thing is, there will always be current flowing through this thing. And when we get to maximum resistance across this rheostat, the light bulb will go out as most of the voltage gets dropped across this thing. Now, that's fine. We've basically turned a light bulb out, except we haven't actually stopped all the voltage on this thing. This is still going to be taking a small amount of voltage. And I can tell that because if I touch it right now, it's actually reasonably hot still. That will of course be the light bulb when it was turned on, but it will also have a little bit of current flowing through this thing, heating it up, which means that there is not 0 volts being dropped across this thing. There's always going to be some slight resistance in there, and that means some voltage will be spent in warming this component up. What a potential divider does for us is it actually brings that down to 0, or at least we can find a 0 result on that one. So let me just show you that now. Okay, so now I've got my potential divider circuit up, and it looks a bit like this now, which is a massive spaghetti junction of wires. I do apologize for my messiness here. But we can see we've got the variable resistor here now, and we have this light bulb in parallel with it. And in series with the variable resistor, we have our nice bomb-proof resistor, which is actually getting reasonably warm. So I'm going to do this very quickly. In fact, just turn that down a bit. There we go. So reasonably quickly, you can see that the light bulb here is on. Okay, and what we're going to do is we're going to reduce the resistance across this rheostat here, and as we do so, the light bulb will go out. The reason for that is as we reduce the resistance across here, less voltage is being dropped across the resistor, and if there's less voltage across the resistor, there must also be less voltage across the light bulb because they're in parallel. So we can keep on going down and down and down, and then when we get to 0 resistance, we end up with, well, 0 voltage here. Basically, all the electrons are quite happy to zip along through this bit here, rather than having to go through something difficult, like the light bulb. And there we go. So that was looking at the potential divider and also the series circuit. And you can see how the series circuit is fine, useful as a dimmer switch, but doesn't actually get you to 0 volts. Whereas potential divider will do that for you. So really quickly, I'm just going to show you a potentiometer now, which is basically a component which does a potential divider for you and gives you a nice sliding scale on it as well. Okay, so now this is set up as a potentiometer, and this is the best way to make a dim ball light bulb. So we start off here. This is now connected on both sides, there you go, to the power pack. And you have the light bulb now in parallel, sort of. The diagram's going to make it a little bit easier to see. But then, what we can do, right now we are on maximum resistance across the resistor, which means that we have all the voltage being dropped across this light bulb right now. It's just easy for electrons to go through. And then as we reduce the resistance, we bring it down to 0, the light bulb will actually have 0 voltage going across it as well. So we can slide up to maximum voltage quite easily, and then we drop it down to 0 volts. Exactly. And there you go. Best way to make a dimmable light switch, because you actually get the light bulb being turned off. Right, so that was a potentiometer, useful bit of kit. I used something called a rheostat for that one. And, well, basically the bomb-proof. You can actually put lots of different current across that thing and it's not going to fail on you, which is why we use them in lessons. But now we're looking at a light sensing circuit. And what we've done here is we've taken a regular or potential divider circuit and replaced one of the resistors with an LDR, a light dependent resistor. Now if you don't know what that is, have a look in the link below. There will be a video there explaining what a light dependent resistor does. But in short, it basically makes the resistance different depending on the light that falls on it. So this thing is going to change its voltage across itself depending on the amount of light going onto it. It changes its resistance, and so the voltage dropped across that particular component is going to change as well. So have a look at the questions there. What happens if the resistance in the LDR goes up? Answer down in the comment below and see what you think works. Hopefully there'll be an answer down there. If there isn't, I'll have to make another video explaining this, but let's see how it goes. And then I want you to consider what's going to happen when it gets dark. You're going to find out how LDRs behave by looking at the other video, but then come back and answer that question there for me, and answer in the forums as well. So then the other thing we need to look at is the exact same thing again, but instead of using a light dependent resistor, Now we're using a thermistor, and that changes its resistance based on temperature. And if it does that, you've basically got a temperature sensing circuit. And then you can attach this to a multimeter, so measuring the voltage on there, or measuring the current flowing, not the current flowing through, just the voltage, measuring the voltage going through. And then you can use that to make a thermometer. Basically, as the voltage changes, then also as the temperature changes, then also the voltage is going to change, which means that you can get a computer or an electronic piece of equipment to sense changes in the environment. And this is why potential dividers are good. They allow us to make really good sensing circuits, ones that will actually change their sensitivity based on the components you use. So there we go. Answer the questions on there as well, and put them in the comments below or onto the forums. So there you go, guys. What you now know is you know what a potential divider does and how you can use it in a potentiometer. You also know how to make various light sensing circuits based off that. Now go away, draw the circuits, and answer the questions that have been put to you, and see if you can make an intruder alarm based on your knowledge now. Okay? Should be fairly straightforward, but here's a bit of a hint. Attach a buzzer to your potentiometer, or maybe attach a light bulb to it, and then see what happens. And there you go. Right, guys, I'll see you in the next video.